Okay, this is now the breaking in setup that I've got here. What I basically did is I left the driver overnight, so roughly about 7 hours or 7 hours and 10 minutes or so, just to loosen the spider a bit more. The rest of the breaking in will be done inside the car, inside the box, but at least as it stands, the spider is more loose and more flexible than from being from the box into the sixth order enclosure. So at least now it's a bit more flex. And as you can see, when I go a bit closer, how much it's moving. I don't know if you can see it. I know what I can see, it's moving quite a lot compared to from when I started it. As I said, look, you know what, the proper way of doing it is obviously a 24-hour break, but I only did it for 7 hours or so, just enough just to loosen it just a little bit. Like I said, the rest will be done inside the car. Also, a big shout out to iRecipes for this tone. I'll leave a link in the description, so that if you guys want to also break in your drivers and that, you can actually use this thing is perfect, because it's from 20 Hertz to 80 Hertz and down, and like in a loop for about 7 hours and 50 minutes or so. But yeah, thanks to guys like iRecipes for actually making things like this for us, DIY or like professional bass heads. Okay, what I did here now is I added a little bit more power so that you can see how the driver moves more now. This is very nice, you know, very satisfactory, especially if you're a bass head, you know, seeing the woofer flex like that. Nice. Okay, this is now the setup that I've done to test the amp. I've got my 2-volt pre-out radio right there with the oscope, and then the amp connected to the battery, and then I'm gonna just connect the RCAs, and then I'm gonna do some tests and see. Okay, now I've got a thousand hertz test tone at -5 dB. So I just want to just to get a figure now of how much each channel is pushing. So, and I'll be doing this on every single channel to make sure that all of them actually work. But just to show you guys, so now I'm gonna start matching the gain with the volume. The volume here is at volume 34. Okay, so what I'm gonna do is I'm gonna slowly turn up that gain until I see any sort of clipping, and I go back. But so far so good. Okay, so far so good. So far so very, very good. Okay, I think that would be the max. So I feel more comfortable being able to go back a little bit. It looks like it's not distorting, but just to be safe, you know, don't set everything at max. Always leave a leeway. So I'm gonna set it right by the amplitude. When the amplitude is high, okay, let's just set. There we go. Right about there. Okay, I'll work it out according to that. Okay, let me just get the phone quickly. Okay, now I've got the Ohm's law in front of me with the phone. So when I input 3.77 volts by, let's just say now 4 ohm load, it gives me 3.5 watts as it stands. But now remember, this is going to change because I am just connecting it straight to the battery. So you're looking at maybe 12 volts or so, 12.3 volts or so, 12.4. When obviously when you have the alternator coming into play, this voltage will actually increase and your wattage will increase. But just as it stands, as it is here, this is how much right now it's pushing at 4 ohms. Then at 2 ohms, which is basically the where it's rated at, it'll be 7.1 watts. Also, sorry guys, also with this here, bear in mind that this is a -5 dB test tone. If I put a minus, or let me rather say a 0 dB test tone, this number will increase. Okay, and obviously if I use a -10 dB test tone, that number will also decrease quite drastically. So bear that in mind, obviously, when I'm busy showing this. But so far from what I'm seeing here, I'm actually happy and it is good so far. Okay, something very peculiar now that I see here. I'm sure it's just obviously normal. One side will always push more than the other side. Basically on the, let me just have a look at the amp quickly. The test was done on the right hand side of channel A, and then I got that 3.77 volts. Now I put it on the left side of channel A. Oh sorry, it went out of that. Let's just go back quickly. Okay, there we go. Now it went on the left side. Now it's at 4.05 volts. Okay, look, maybe that point, I think what, a 0.3 won't really make much of a difference. But this is how it is as well, you know. Even with us humans, you know, your one side is better than the other side. So nothing will be 100%, but it's very close. That's all that matters. It's very, very close. It's not way off like by a volt or something, or a third of a volt or something, or half a volt. It's just that 0.3 volts, which is fine. Okay, so now this is a 50 hertz tone. Everything is set also according to volume 34 on the deck. But now, as you can see, that's a hot clip. Okay, so bear in mind that obviously now I'm just testing one channel to see how much power I get. But so what you obviously do is channel A would then be just for your mids, tweeters and 6x9s and all that. So obviously you will set channel A accordingly, according to the volume, according to that 1000 hertz test tone, or even the 500 hertz test tone. Sorry, at -5 dB as always, nah? And then when you go over to channel B side, okay, then you have to obviously match channel B to the volume to get your maximum power. Right now I'm gonna set it down. I'm gonna adjust the gain down. Okay, so the gain will go down. I'm gonna go down quite far, and then I'm gonna go up a little bit just to see the point of clip. I think it's just about there. Yeah, it's about there. Okay, so what I normally do, I always don't go all the way up. I'll try and maybe go to 31 volts or 30 volts. It's fine. Okay, go back. Oh, seems tricky to adjust. Okay, that's fine. 30.441 volts. Okay, now going back to the Ohm's law. Okay, so this will be obviously running at 4 ohms, and then the 6x9s, or the other channels, 6x9s, mids, tweeters and that I can go all the way to 2 ohms if I need to. But unfortunately with the 4 channels, most of them, basically all of them I can say, once you start bridging, you're getting only a 4 ohm load onto that. So now if I now input the new data, it's 30.41 by 4 ohms. As it stands with this 2 volt pre-out radio, it'll give me 231 watts RMS. Very impressive. And remember, I still went down a little bit. so I can go a little bit up, way more than actually anticipated of what this thing can do, because the book stated that it's 190 watts breached. So knowing this kind of information, what I then can do is, with a 6 order bolt, I can actually send the power. Okay, it's obviously going to be different now because it's going to be a factory deck, so it's going to be tricky, and those factory decks, I think they 1 volt pre-outs, so I'll have to do maybe a couple of tests beforehand to actually find the sweet spot of that radio, and then adjust it accordingly. But I will try and squeeze out, let's say for argument's sake, by 150 watts out of that radio, if I'm lucky. I think I'll only be getting about 100 watts, I think, but I'm gonna gun for 150 watts. But 230 odd watts, that's very impressive, guys. That's very impressive. I would recommend this amp any day. Like I said, with the other side of the, without bridging it, bear in mind that it's also, like I said before, the test tone is at -5 dB. Your alternator is not into play, so your voltage is not as high. But also remember that you also don't want your mids and net to be so high. High frequencies are killer to the ear. So for me, it's fine. The way it's that wattage, it's fine. It'll actually just blend in and work out right. Okay, so now I'm gonna do the test on the other side, channel B, and all the other channels, and then it'll be good to go then. Sorry guys, I realized I made a mistake with 1000 Hertz test tone. As you can see there, okay, the mistake was I had my crossover set on LPF, so obviously it was cutting out the highs a lot. So now all I did is I just set my crossover to HPF, and as it stands, this is now the max I can get out of that. Okay, so looking at the graph, or let's just say the Ohm's law, that's 14.70. At 4 ohms I'll be getting 54 watts RMS, and then at 2 ohms it's going to be a lot. I can get 108 watts RMS, but this is now at the max of it, and I don't like setting the gains all the way to the point of max, because the minute you put in a load, there's not even a possibility it's going to clip if you're going to go full tilt. So assuming that you're not going to clip, but you will clip the minute you put a load onto that. So I always, wherever the max is, I would then just minus 10-20% of that, or 15% more or less. But yeah, sorry guys, it's an honest mistake I made, hence the name Noob Master. Okay, some parts I might look, or others might look and say, yo, this guy is masterful, skillful, and then other parts and other times I'll have a moment like this. This is a noob moment at its best. But yeah, anyway, thanks, I rectified my mistake. That's how we all learn. Make a mistake, you figure it out, you come back, you do it right. I'm very pleased with the results and the tests that I've done on this boss of an amp for 4-channel Pioneer. It actually is better than what I expected for the price tag behind it, and it being a 4-channel. Well, advantage number one, it's a Pioneer. So Pioneer is very good. It's not a Mickey Mouse brand as well. And I've tested all the other channels, channel A and B, both each channel and bridged, and basically they're the same. So as it stands this year, I would buy it, another one, in a heartbeat. I wouldn't even make a mistake. I wouldn't even think twice. I would buy it, because the data that they put up here, is basically the same and a little bit more in a real world test. It's just a real world test. What happens is you don't go full out. You can go all the way up there, but if they say 70 watts RMS and I can get 100 watts, I'll rather stick with the 70 watts RMS, and I know I'm 100% safe. 100% safe. I can go full tilt, no worries, no problems. But this, as it stands, this here, any day, anybody coming to ask me for a 4-channel, this is one of those 4 channels I would recommend to somebody to buy. Coming up would be now basically the building of the box, and then basically the assembling of the box with the sub in it. Coming up, the 6th order. I forgot. I've got 2 of these decks here. This is now that obviously with they look identical, but can they perform the same? So with that being in mind, the one is a 2 volt pre-out, the other one is a 1 volt pre-out. Now this will be an upcoming video about these 2 brands and which one is better. Is it the Targa, this side here on my left, or is it the Star Sound on my right? Bear in mind I did this test with the Star Sound, so with the Targa it'll be similar, maybe, who knows. Only way to prove it is to test both radios and just to see which one would be a better buy if you got if you're in the lookout for a deck and don't want to break the bank. And also these 2 decks are the same price, but one is better than the other one. That's one thing for sure. This is now the layout of that 6th order band pass that I will be building. It's a bit late now to actually start the build, and I'm a bit lazy now to actually join these pieces together. So this will be a build for the following weekend. That's how I want to do it. But just to give you guys an idea, this is how it will look more or less when it's complete. Just roughly I put it together. As you can see here, this is the lows, and then this is for the highs. So I think this will be banging. And then I'll just when I do the build next week, then I'll talk more in depth about the 6th order and why I picked this particular one for this build.